to derive the area equation of a slope of tangent line, which is of course, let me type it first, is limit h when it approaches 0, f of x plus h minus f of x over h. And I'm going to teach you, and first thing we're going to do is draw the x. Oops, that's not an y-axis. We're going to draw first the y-axis and the x-axis, and we're going to draw the function that we're going to find its slope. Let's draw this function. Let's name it f of x, or yeah, f of x. Oh, no need to name it at all. Now let's say this point is x, and its final point it's x. Now it's important. Why is that? Because this point is equal to q, and this point is p. Okay. Now the distance between those between x and x plus h. Why is x plus h? Let's say, for example, this one 3 and that was 10. We're gonna, the difference between them is 7, and h is going to be a 7. That's just an example. So h is just the difference between x and x plus h. That's all. So that's where h come from. Now let's do this point P and Q. Okay, we're going to find slope of a tangent line. Let's say this is a tangent line. Tangent line, when we get to a Q really close to P. Let's say, for example, Q gets really close to P, and the only way it can happen that if x is equal to x plus h, or kinda equal to x plus h, like 1.999 is kinda equal to 2. So the only way that it could happen that if h is really close or to 0, and the definition of something getting really close to something is a limit. So let's keep that in mind. Now, of course, let's find the slope of this function, which is, of course, the slope is m, which is equal to rise over run. Rise is going to be, of course, let's name this point P. That's from the x-axis, and from the y-axis is f of x, and this point Q, and in the x-axis is x plus h, but in the y-axis it's f of x plus h. Now rise is delta y over delta x, which is the difference between delta y and the difference between delta h and delta x, and delta y, which is f of x plus h minus f of x. Why is that? Because delta y is y minus y naught, or y minus y sub 0, divided by delta x is x plus h minus x, and we delete the x's, and we get m is equal to f of x plus h minus f of x, which is equal to divided by h. Now we want the q and b getting really close to each other, and the only way that could happen is the difference between them becomes or getting so close to 0, and the definition of being so close to 0 is the limit. So the limit of h when it approaches 0, and because we gotta do it on both sides, it's equal to limit when h approaches 0, f of x plus h minus f of x divided by h. Okay, now the limit of h when it approaches 0, m is equal to m, because m is just a number. is equal to limit h when it approaches 0, f of x plus h minus f of x divided by h, and that's the equation or the slope of tangent line at any point P.